Question 15 is about similar triangles. Here they are asking us to identify whether they are similar triangles and then find the measure. If you focus on finding the measure, that's more than enough, because generally these are, electronic questions. You will have choices and they'll just give you the x values. But now looking at this figure, they have told this angle is equal and this is 90. Obviously then this will be similar because all the three angles must be same. Now then, if this is the side I'm considering, 15 divided by the other side would be 12, or I can write the same triangle. I'm just writing the other side. This will be equal to, I've chosen this triangle, so I choose the other side of that same triangle first, x plus 5 and x plus 1. So let's solve this up. This goes to the other side, be 15 into x plus 1, cross multiply, and that is equal to 12 times x plus 5. Now then it will be 15x plus 15, that is equal to 12x plus 15 times 5 is 60. You can directly put this in the calculator and solve. You don't need to do all this. I've shown in the previous problems. Directly in the calculator you get the answer. Since 15x, I'll leave it over here. I'll bring the smaller x value to the other side, that's 12x, and this goes to the other side, 60 minus 15. Here you will get 3x, that is equal to 45. The answer of x is 15. So that is the answer. Just by the triangle proportionality statements, we will find it out. And now I forgot to see the question. They have not told you to find the x value. They are told to find AC. It's x plus 1. 15 plus 1 is 16. So that is the correct answer, 16. Okay. Now what about JL? Now it's not x, it's JL. So you need to find whatever x is there plus 18. Now first of all, are they similar? Since these are parallel, these are vertical opposite angles, and now you can tell these are alternate angles, alternate opposite angles, interior alternate angles. So yes, they are similar if two angles, and this also is equal to this. Now then we will use the proportionality statement. I will take these two at the ends, 16 divided by 4. Okay, first is the bigger, then divided by 4. I can then make it equal to x plus 18 because I chose 16, then the same triangle side first and divided by x minus 3. I just put in the calculator and I get the answer. All you need to do is 16 divided by 4, that is 4 itself, answer over here. But let's write in fractions as it is. And we have x plus 18 divided by x minus 3. Shift and solve, then press equal to, you get the answer 10. So the answer over here is 10. But now that is x value, then add 18 to it. Again, I forgot JL, add 18, it'll be 28. So that is the answer, JL is 28. Similarly, you can solve this one as well. Here they are similar because these two are parallel, then these are corresponding angles, same angle, corresponding angles. Now then we will use the statement, this is known. Okay, now here we can use this easily. 6 divided by 12, that's fine. Why? Because it's small triangle, big triangle. But now what I need to do is, small triangle side is how much? X plus 5 divided by, what is the big triangle side? It is x plus 5 plus 9, because the entire side, see, so much is x plus 5. For the small triangle, 6. But this one is the side of the big triangle, so the entire length must be taken, x plus 5 plus 9. Now, you don't need to solve it. Again, I'll show you directly in calculator. All you need to do is type it out. 6 by 12, that's half, will be equal to x plus 5. Okay, now I need to write the fraction first, only then it will be proper. X plus 5 divided by x plus 5 plus 9. Don't think it cancels off. It's not x plus 5, it's x plus 13 here. Shift and solve, and the answer is 4. But what do we need to find? We need to find EH. These two sides are same. Looking at this, you can tell if this is x plus 5, this is also x plus 5. Why? Because I have told this is 9, this is 9, right? So these two are same. The total length will be x plus 5 itself. X plus 5 plus 9, right? So now we have to do 4 plus 5, that is 9. That will be the answer. You can see, because these are equal to each other, we can apply the x value to this x plus 5 and easily find the total. The EH value is supposed to be 9 because EH and EG are equal. Now similarly you can do this one again over here, corresponding angles and same angle, and you can easily solve it up. I'll write the similarity statement. Please try pausing the video, do it by yourself and then continue. Here I'll take the big triangle first, 14 divided by small triangle 6. Now here, if I've taken this entire thing, I have to take this entire thing, not just the small one, okay, or this one. I take the entire values. So here is equal to 3x minus 3 plus x plus 2. This is the statement because I have to take the entire length, right? And for the below one, it's just the small triangle. It's x plus 2 because I've chosen 6 down, right? I have to write x plus 2 down. Above it was 14 total length. This is the thing. You can directly put this in the calculator. Since it's too big, I'll just solve this anyways. Here, before you put it in the calculator, you can easily simplify this a bit. You can directly put it, no problem. But this becomes what exactly? It'll be 4x minus 1 divided by x plus 2. Or you can put the entire thing. Up to you. It'll be 14 divided by 6 here. That equals, here it's going to be 4x minus 1 because minus 3 plus 2 is minus 1 divided by x plus 2. Shift and solve and then press equal to, it's 3.4. That's the x value, but what is Vt? Vt will be plus 2, it will be 5.4. That's the answer. And now we have some real world problems. Olivia draws a regular pentagon. Pentagon means having 5 sides and regular means all the sides are equal. And starts connecting its vertices to make a 5-pointed star. Okay, she wants to do a 5-pointed star. But after just drawing 3 lines in the star, she becomes curious about the 2 triangles that appear in the figure. Can you see this ABC and CEB? These are the 2 ones. You can see over here ABC, this one and this one. They look similar to her. Prove that this is the case. We basically have to prove it's similar. So they have told it's similar itself. We just have to prove it. So how we can prove over here is, since it's a pentagon, we know the total angle of a pentagon is n minus 2 times 360, isn't it? So what are the sides of a pentagon? It's 5 minus 2 times 360. So, sorry, it's not 360, it's 180, my bad. The formula is n minus 2 times 180 degrees. 5 minus 2 is 3, 3 times 180 would be 18, 36, 54, right? It should be 540 degrees. So that will be 3 times 8, 540 degrees, the total angle of pentagon. But now what are the angles? Because we know it's a regular pentagon, all the sides are equal, the angles or the vertices also are equal. So just divide this by 5, you'll get the answer. 5 will be 100, 45s are 8, 108 is the answer. So what we came to know is each of these vertices are having a degree of 108. Now let's focus on what are the 2 triangles. This one, BEC, and total, another one is ABC. So this one, these 2 triangles. Over here, I know for sure that B and B is equal because it's the same angle. So done. We need to prove any one other one is equal, any one of the angle. Okay. So then we can do one thing. Let's try to break down. We know this is now 108 degrees. Now everywhere, all the vertices are 108 degrees. So let us try to find these angles. What about that? This total angle in a triangle. Now one thing you need to remember, these sides are all same. So this is an equilateral triangle, isn't it? So here if I take x and over here also x, and this is 108 degrees. So 180 degrees will be equal to 108 plus 2x, isn't it? Take this to the other side, 108, it will be 70, 70 plus 2, 72 degrees equals 2x. Divide both the sides by 2, it will be 36 degrees. That is x. Now then, we know this over here is 36, 108, again 36. Now, what about the other sides? Same thing will happen over here, 36, 108, 36. Now, if you know this is 36, 36, what is the remaining one? 72 minus 108 minus 72, because total is 108 minus 36, 72, 72. Oh, it's 36 itself. So 36, 36, all these are 36. Now then, I know A is 36. What about this side? This is also 36 degrees. Now this one is 72 degrees, but we don't we have this already. 1b is same for both the triangles, and now 36 and 36 is same, so no matter what, this must be equal. I mean, this is similar because of a similarity, so directly we can prove it. Why? Because this is a common angle for both the triangles, see BEC or ABC, and we came to know this is 36 degrees and this one is also 36 degrees. So they two angles are same, so we can tell a similarity, and hence they are similar. You can see over here they have done the same thing, finding 36, and they have found this also as 72, and then they have just told it's similar. Now what about this one over here? Write as many triangle similarity statements as possible for the figure shown. How do you know that these triangles are similar? Now these are very easy. Whenever you have 90 degrees like this blocked up, let's look into the full triangle first, AEG over here, and then let's look at AHB. Okay? If you see, this angle is common for the bigger one and the smaller one, right? It's common over here and the big side. So if this is any angle, it's the same for both. Then what about this 90 degree here, this 90 degree? Two angles are common, so I can easily tell these two are similar. Same way, let me go with other one. This and this. This and this I can take. I know A and A is common for both of this and the smaller one, and then there's 90-90, so it's similar because of A similarity. What about this one here? Those triangles. Now this is similar over here and having a E common because the whole triangle and this one is having EE same and 90 degree, and over here there's 90 degree. So easily whenever you have 90 degree and then a common side, sorry, common angle, you can easily tell they are all similar because of A similarity. That's the answer. Even over here you can easily tell this one. Now what they want is find JKL, the whole thing, and JMK. See, this much and the whole triangle. Let's look into the whole triangle. This is 90 degrees. What about the smaller one? This is 90 degrees. So one angle is done. A is done. What about the other angle? Now JKJL is congruent to KJM because these two triangles have a common angle, so there are two angles equal, so then the third angle must be equal. So because of A similarity, we can easily tell they are similar. So they are similar basically. So that's the thing, we can easily prove them, and that's the end. Just some reasoning is required, but since it's a multiple choice question, you can stick with finding the x value rather than proving problems are there in the writing part. You can go back to the writing part videos where everything is proven. I would suggest you to stick to finding the x values rather than proving in the electronic part.